Quantum Sensing in Space, Exploring the Universe with Quantum Technology. Title: Quantum Sensing in Space, Exploring the Universe with Quantum Technology. Introduction. In the vast expanse of the cosmos, scientists and astronomers have long sought answers to the mysteries that lie beyond our planet. One of the most powerful tools aiding this exploration is quantum sensing, a revolutionary technology that allows us to push the boundaries of knowledge. Quantum sensing in space has opened doors to new frontiers, enabling us to delve deeper into the universe and unravel its enigmatic secrets. This article explores how quantum technology is transforming our understanding of space and propelling us into an era of astounding discovery. Unleashing the power of quantum. Quantum sensing harnesses the fascinating principles of quantum mechanics to enhance our ability to measure and observe the universe. Traditional sensors have limitations when it comes to accuracy, precision, and sensitivity. However, the emergence of quantum-based sensors offers unprecedented enhancements that push the boundaries of what is possible. Quantum sensors in space. Quantum sensors have found a myriad of applications in space exploration. One of the most striking examples is the use of quantum clocks for satellite-based navigational systems. These clocks utilize the phenomenon of quantum superposition, allowing them to maintain precise time measurements over prolonged periods. This capability is crucial for accurate navigation, as even minute timing errors can lead to significant deviations over long distances. Another significant application is the use of quantum magnetometers in studying celestial bodies. Traditional magnetometers are often bulky and susceptible to external electromagnetic interferences. However, quantum magnetometers employ the property of quantum entanglement, providing unparalleled sensitivity to detect and map magnetic fields with astonishing precision. This helps scientists investigate the magnetic properties of distant planets, moons, and even stars, unraveling the mysteries of their composition and dynamics. Quantum gravity sensors. Quantum sensing extends its reach to the study of gravity, offering revolutionizing applications in space. Quantum gravity sensors use atom interferometry to measure gravitational forces with high accuracy. By exploiting the delicate quantum states of atoms, these sensors can detect gravitational variations at levels unimaginable with classical technologies. This creates exciting opportunities to study gravitational waves, dark matter, and other fundamental aspects of the universe's fabric. Quantum communications in space. Communication plays a vital role in space missions, requiring reliable and secure transmission of data across vast distances. Quantum technologies also offer a solution in this domain through quantum communication systems, leveraging the unique property of quantum entanglement. Quantum communication ensures an unparalleled level of security, as any attempt to eavesdrop or tamper with the transmit to data would inevitably leave traces, thereby alerting the users. This development paves the way for quantum key distribution, enabling unbreakable encryption for sensitive space missions. Overcoming challenges? While quantum sensing in space presents incredible opportunities, it also faces challenges that must be addressed for further advancements. Miniaturization is crucial since space missions often involve compact and lightweight payloads. Developing smaller and more robust quantum sensors will be essential in enhancing the capabilities of future missions. Furthermore, space is an extreme environment with intense radiation, extreme temperatures, and prolonged exposure to vacuum. ensuring the resilience and stability of quantum sensors under such conduct. Ions require advanced engineering and design. Researchers are actively working on developing materials and building techniques to overcome these challenges and enable the full potential of quantum technology in space exploration. The future of quantum sensing in space. As quantum technology continues to evolve, its potential to revolutionize space exploration appears boundless. From studying distant galaxies to unraveling the nature of dark matter and mapping gravitational waves, quantum sensing is charting a new path for our understanding of the universe. The combination of quantum sensors with artificial intelligence and machine learning holds tremendous promise. Acknowledging the mysteries hidden within the vast expanse of the cosmos, researchers and astronomers have tirelessly strived to decipher the enigmatic secrets that lie beyond our planet. Quantum sensing, a groundbreaking technology, has emerged as a powerful tool that aids in the exploration of space, pushing the boundaries of knowledge further than ever before. This article delves into the transformative role of quantum technology in expanding our understanding of space and ushering us into an era of remarkable discovery. Quantum sensing is based on the mesmerizing principles of quantum mechanics, which provide a means to enhance our capability to measure and observe the universe. Traditional sensors have inherent limitations in terms of accuracy, precision, and sensitivity. However, the development of quantum-based sensors has introduced unprecedented enhancements that push the boundaries of what is achievable. These quantum sensors find manifold applications in space exploration. The utilization of quantum clocks in satellite-based navigational systems is a striking example. By capitalizing on the phenomenon of quantum superposition, these clocks can maintain remarkably precise time measurements over extended periods. This accuracy is crucial for navigation, as even the slightest timing errors can lead to significant deviations over vast distances. Another significant application lies in the use of quantum magnetometers to study celestial bodies. Conventional magnetometers are often plagued by bulky designs and susceptibility to external electromagnetic interferences. Quantum magnetometers, benefiting from the property of quantum entanglement, exhibit an unparalleled sensitivity to detect and map magnetic fields with astonishing precision. This empowers scientists to investigate the magnetic properties of remote planets, moons, and even stars, unraveling the mysteries surrounding their composition and dynamics. Quantum sensing also extends its influence to the study of gravity, offering groundbreaking applications in space exploration. Quantum gravity sensors employ atom interferometry to measure gravitational null forces with exceptional precision. By exploiting the delicate quantum states of atoms, these sensors can detect gravitational variations at levels unimaginable with classical technologies. This presents exciting opportunities for the study of gravitational waves, dark matter, and other fundamental aspects of the universe's fabric. Communication plays a vital role in space missions, necessitating reliable and secure data transmission across vast distances. Quantum communication systems address this challenge by harnessing the unique property of quantum entanglement. Quantum communication guarantees an unparalleled level of security, as any attempt to intercept or tamper with the transmitted data would inevitably leave alerting the users. This breakthrough paves the way for quantum key distribution, facilitating unbreakable encryption for sensitive space missions. Despite the incredible opportunities presented by quantum sensing in space, it encounters challenges that demand attention for future advancements. Miniaturization is of utmost importance, as space missions often require compact and lightweight payloads. Developing smaller and more robust quantum sensors will be crucial in enhancing the capabilities of future missions. Additionally, space is an extreme environment characterized by intense radiation, extreme temperatures, and prolonged exposure to a vacuum. Ensuring the resilience and stability of quantum sensors under such conditions mandates advanced engineering and design. Researchers are actively working on developing materials and building techniques to overcome these challenges and enable the full potential of quantum technology in space exploration. As quantum technology continues to evolve, its potential to revolutionize space exploration remains boundless. The integration of quantum sensors with artificial intelligence and machine learning holds tremendous promise. This synergy facilitates further breakthroughs in space exploration. Quantum sensing in space is a revolutionary technology that allows us to explore the cosmos and uncover its mysteries. By harnessing the principles of quantum mechanics, quantum sensors offer unprecedented accuracy, precision, and sensitivity that go beyond the limitations of traditional sensors.